Hello students, how are you? Doing well? Very good. Dear students, we have been learning very important organic chemistry chapters. In previous lecture, we have completed alcohols, phenols and ethers. Today, we are going to learn very important organic chemistry chapters is aldehydes, ketones and carboxylic acids. That means carbonyl compounds. These are the compounds which plays a major role with respect to name reactions, oxidations, reductions, CC bond formation, CC double bond formation and various metal catalyzed reactions. So this category of compounds plays a very big role in organic chemistry. However, we will learn in detail about their preparation, structural elucidation, their nomenclature and various methods available for the preparation of aldehydes and ketones, and we are going to learn chemical reactions which undergoes these compounds aldehydes and ketones. Yes students, so let us see one by one. Yes students, please subscribe my channel Venus Academy if you are not yet subscribed, and don't forget to click on like button and bell button. Dear students, let us see the chapter. And while live is going on, you can question if you have any doubts while live session is going on about this topic or previously taught topics, so that I can answer if possible now itself or I can answer later also. So please write your queries in comments box and don't forget to click on like button and bell button. Let us see the topic. Aldehydes, ketones and carboxylic acids. These are the compounds having carbon attached to oxygen with double bond, and if the R is hydrogen, these are aldehydes. If R is alkyl or aryl, two sides, then these are ketones. So what is the structure? This is the carbon having double bond with oxygen and two carbons or hydrogens with CC single bond. Overall hybridization of carbon in carbonyl compounds is sp2 hybridization. What is the shape of sp2 hybridization? It is trigonal coplanar. Since it is planar, the bond angle between these two substituents or between this and this is about 120 degrees. So it is sp2 hybridized molecule where carbon is having double bond with oxygen, and remaining substituents, if R equal to hydrogen, then they are known as aldehydes, and R if it is alkyl or aryl groups, then two sides if it is aryl or alkyl groups, then it is known as ketones. Yes students, the bond angle is 120 degrees and 120 degrees. What else? These compounds are highly polar because the oxygen is electronegative atom which pulls this electron density towards it to attain partial negative charge, and this carbon attains partial positive charge. And the bond between carbon and oxygen is a pi bond, where oxygen will use its p orbital to form pi bond, side-on overlapping pi bond. So overall carbonyl compound is going to have 3 sigma bonds and 1 pi bond. The hybridization is sp2 hybridization. This is the structural elucidation of carbonyl compounds. Then what are the common carbonyl compounds we come across? For example, if it is a hydrogen and R can be alkyl or aryl, it doesn't matter. These are aldehydes. If R equal to alkyl or aryl and this side alkyl or aryl group, then these are known as ketones. And one more important category of compounds under this category is carboxylic acid. If this hydrogen or R group, in place of this, if it is substituted with hydroxy group, then these are known as carboxylic acids. These are the 3 category of compounds where carbon is having double bond O. Yes, students? So further it can have acyl chlorides or acyl halides. It can have esters. It can have amides. It can have anhydrides. These are all comes under the category of acids, whereas aldehydes and ketones, for example, this is acetaldehyde. And its common name is acetaldehyde. When it comes to IUPAC nomenclature, it is named as ethanal. So in place of alkane, where you will write ethane, this is ethane, you have to add Al. Al stands for aldehyde. For example, here this is 2-propanone is an IUPAC nomenclature, and the common name of this compound is acetone. So these are all aldehydes, these are ketones. So the common aldehydes or ketones we come across are here. The starting 1 carbon containing aldehyde is formaldehyde. This IUPAC nomenclature is methanal, Al, methanal. And 2 carbon containing aldehyde is acetaldehyde. Then comes propionaldehyde, and very important compounds under this series is aromatic aldehydes. This is benzaldehyde. And when benzaldehyde is substituted with hydroxy and methoxy groups, it is known as vanillin. What we use in ice creams, vanillin. So it is isolated from vanilla seeds. When it comes to cinnamaldehyde, this cinnamaldehyde is isolated from cinnamon. And very important, another compound is salicylaldehyde. Yes, students? So cinnamaldehyde this is salicylaldehyde. When it comes to ketones, this is acetone and it can have benzene ring one side, and this is acetophenone. Though each compound is having IUPAC nomenclature, but commonly these ketones are known with their common names, acetophenone, propiophenone, and if two sides this methyl is also substituted with benzene ring, then it is known as benzophenone. So these are all, you can write n number of compounds with different structures. It doesn't matter whether this group, it can be alkyl or aryl, and it can be alkyl and aryl. Whereas this aldehydes, this alkyl or aryl or heteroaryl. For example, this is furaldehyde or for fural. So it can have heterocyclic aldehyde or alkyl aldehydes or aryl aldehydes. So the common factor or the common structure which is we come across is RCOH. Is this is commonly written as R. Aldehydes are commonly written as RCHO. Ketones, yes, this way you can write. So these are the compounds having carbon with attached to alkyl or aryl groups. Let us see their preparation, then we will learn about their IUPAC nomenclature. So that once we know the preparation methods, simply we can name the compound based on their preparatory starting materials. So these are aldehydes, ketones. Let us learn their preparation methods. Dear students, if you have any queries or doubts, please write in comments box. I am teaching very slowly and in a systematic way so that a new learner or the student, those who are in 12th class now, they can understand. because of this coronavirus, most of the students are not getting classes online. At the same time, though online classes are taken by some lecturers or some institutes, they are teaching from different textbooks or guidebooks. However, CBSE board or JEE means or NEET follows only NCERT books, students. So please concentrate on NCERT books so that you will get all questions from NCERT books only. If you get any question out of NCERT other than NCERT, then that question will be invalid and you will get bonus point. So mostly concentrate on NCERT books. Yes, students. Yes. So let us see the common methods for the preparation of aldehydes and ketones. So what are the general methods available for the preparation of aldehydes or ketones? We have already come across the oxidation of alcohols. We will get aldehydes and ketones. Let us see. If I take primary alcohol, let us take acetaldehyde and upon oxidation so the common oxidizing agent is chromium trioxide, and I have explained during alcohol's oxidation. So we can use chromium trioxide in sulfuric acid. It is Jones reagent. If I use chromium trioxide, sulfuric acid in dichloromethane, it is Collins reagent. Then another important category of compound is pyridinium chlorochromate. Pyridine with HCl plus chromium trioxide. It is known as PCC. Pyridinium chlorochromate. So this is almost neutral reagent, and this reagent name is SARET reagent. So PCC reagent or whatever reagent you want to use, you can use to oxidize primary alcohols to. These alcohols are going to give this oxidation, that is acetaldehyde. In place of primary alcohol, if I take secondary alcohol, for example isopropyl alcohol and PCC I am going to use, it is going to give ketone. This is common name is acetone. So like this oxidation of alcohols, we can get carbonyl compounds. The whatever the alcohol we take, you are going to get, if it is primary alcohol, you are going to get aldehydes. Secondary alcohols, you are going to get ketone. If at all, if you use tertiary alcohols, so these compounds do not undergo simple oxidation to aldehydes or ketones. If at all, if you use KMnO4 like strong oxidizing agents, they undergo carboxylic acids with different number of carbons. So simple oxidation tertiary alcohols do not undergo, whereas primary alcohols gives aldehydes, secondary alcohols gives ketones. Dear students, it is very simple. Just remove hydrogen from here and here, and in this case, so minus water, so minus hydrogen, you are going to get aldehydes or ketones. Then another method is, I have explained during alcohol chapter, passing alcohol's vapor through red copper tube at high temperatures, it is going to give aldehydes or ketones. For example, primary alcohols, when I pass through, these are vapors of, since high temperature, it is going to be in vapor state, 300 degrees centigrades. Copper tube, red hot copper tube, when I pass vapors of alcohol, I am going to get aldehydes, primary alcohols. I am going to get aldehydes. If I use secondary alcohols, let us take same isopropanol like compound, and when I pass through copper, it is going to give ketone. Next, students, so these are common methods. Next, another method which is known for the preparation of aldehydes or ketones is ozonolysis. So what is ozonolysis? Let us take one example and see. If I take propene and when I do ozonolysis, when I pass ozone, it is going to break here. The simple way is add oxygen to this side. I made a separate video on this ozonolysis. If you want detailed mechanism with lot of examples, please go through that video. I am going to give the link below of this video. Yes, so for our understanding, it is for the preparation of aldehydes and ketones. Whatever the compound you get with double bond, just break the double bond and add oxygen towards two sides. Yes, so however, it is going to give ozonide like hut like shape. So just ozonide structure is, it is like hut. Yes, so ozonide and this, when we treat it with zinc and water, it is going to give carbonyl compound. This is acetaldehyde when I take propene, and this side it is formaldehyde. What is the common name of this formaldehyde? Methanol. Yes, students, you can post your questions, right? Surendra Mishra, what's your doubt? Okay, methanol, and this is ethanol. Yes, Mishra, you can write again if you have doubt. Yes, so this is ozonide. Next, when I take this 2-propene, methyl 2-propene, 2-methyl propene, this is 2-methyl propene. So how to write? So I can write CH2 here, CH3. Yes, if you want you can write, and simply break here, and when you add ozone, you can write the structure like this, CH and O, CH2. This is ozonide, and when we treat this ozonide with zinc and water, it is going to break to give acetone, and this side what we are going to get? This is methanol, that is formaldehyde. Dear students, whatever the compound, it has been asked in all entrance exams, especially JEE Means and NEET. Every time you are going to get one question. So simply they will take this cyclohexene and they may put here double bond or here double bond, whatever they, wherever they want they can put double bond, and they will ask the compounds. Yes, so it has been asked every time in JEE Means and NEET. Even in 2020 also we had you got this question from ozonolysis. So please go through complete detailed mechanism of ozonolysis what we learnt during previous class, that is hydrocarbons lesson. Yes students, so methyl propene gives this. So whatever the double bond, let me check this. So if I have double bond here, what I am going to get? Just break here, I am going to get dialdehyde. So here double bond, here double bond O. So this is the way you can add oxygen to these alkenes. Next, so very important methods for the preparation of aldehydes and ketones is hydration of alkynes. Yes students, by hydration of alkynes. So alkynes, what we are going to get are Markovnikov's products. So what we are going to get, for example, if I take, what is this compound? Ethyne or acetylene. This acetylene, when I treat it with water in presence of sulfuric acid, that is acid and mercuric sulfate. So this co-catalyst, it is going to act as co-catalyst. So sulfuric acid, it is going to give H plus ions. These H plus ions are going to be taken up by, added to this to give carbocation intermediate. Now this OH, what is there in water, is going to add to this to give what is this compound? Is it going to exist? Vinyl alcohol. Vinyl alcohol is nothing but tautomer of acetaldehyde. How? It is going to shift here to give this single bond and hydrogens, two hydrogens are there. and this hydrogen is coming here. So tautomer of acetaldehyde. Acetaldehyde can be prepared starting from acetylene by hydration. So this is the only compound where we are going to get aldehyde. So higher than this, we are going to get ketones. For example, if I take 2 propine or propine CH3 CH. So here what I said, Markovnikov's addition is going to take place. Here H OH minus. So the first step, what we are using, sulfuric acid and mercuric sulfate. It is going to have H plus ions. So the whatever H plus ions there in the reaction mixture will be added to this to give, there is a chance of getting 2 carbocations. This is one carbocation. So newly added hydrogen is here. This is secondary carbocation, and it also can form, there is a chance to form this carbocation, right, where this hydrogen is coming onto this carbon, and this is primary carbocation. So among these 2 carbocations, which is more stable, this secondary carbocation is going to be more stable. So it is formed major, and it is going to undergo to take nucleophile, that is OH, which is there in the reaction mixture, will be added to this carbon to give and double bond CH, and already one hydrogen is there. So this is, what is this? Enol. The common name of this type of compounds are enol, and these enols are nothing but tautomers of ketones. CH3 double bond O CH, and already this hydrogen is here, and this hydrogen is coming onto this. So now it is acetone. Acetone is a ketone. So this is how the common methods for the preparation of aldehydes and ketones can be followed, starting from alcohols by oxidation or alcohols passing through copper at high temperatures or ozonolysis, and from alkynes. So these are general methods for the preparation of aldehydes and ketones. Let us see specific reactions where you can prepare aldehydes, exclusively aldehydes, and exclusively ketones, where these reactions gives exclusive specific compounds. Let us see one by one. Yes, students. So, dear students, let us see the preparation of specific aldehydes. At the beginning, what I said, the aldehydes and ketones are the important compounds where we come across a number of name reactions for the preparation as well as their chemical reactions. Dear friends, dear students, if you are not yet subscribed my channel, please subscribe my channel Venus Academy if you are not yet subscribed, and don't forget to click on like button and bell button. Dear students, let us see the preparation of aldehydes by Rosenmund reduction. Rosenmund reduction. So it is very simple, students. The name is Rose and Mund. So Rose and Mund reduction. What it is? Acyl halides, for example, benzyl chloride. This is benzyl chloride. When I treat it with hydrogen in presence of palladium carbon, so it is going to reduce halogen to hydrogen, and this carbonyl compound is going to be stable when only the condition is I have to add barium sulfate. So in this barium sulfate, the sulfur which is there as sulfate, this sulfur is going to act as poison for the activity of palladium, where barium, this sulfur behaves as a poison towards this palladium, and it stops at aldehyde stage only. This is aldehyde, where this chlorine is reduced to hydrogen. If I do not add this barium sulfate, very important, students, if I do not add barium sulfate, it is going to undergo further reduction to alcohol. Yes, so Rosenmund reduction is use of barium sulfate. Yes, so similar reaction we come across during alkynes. So alkynes to alkene can be done by palladium carbon by the addition of, yes, so barium sulfate. So sulfur is a poison where it stops at aldehyde stage. In Lindlar's catalyst, yes, it stops at alkene stage. So Rosenmund reduction, one method. So specifically we are going to get aldehydes, and the second method is from nitriles. Let us take nitrile, and when I treat it with stannous chloride, tin dichloride, stannous chloride in presence of HCl, I am going to get aldehyde. Yes, students. So let us take one example and see. And this intermediate is going to be double R CH double bond N H. So this upon hydrolysis, it is going to give aldehydes. Yes, so it is very specific reagent where stannous chloride is going to reduce only nitriles. In this case, double bonds are intact. Let us take double bond containing compound. This double bond, if I do using hydrogen palladium, this is going to be reduced to alkane, RC. This double bond is going to reduce to single bond. However, if I use this SnCl2 in presence of HCl, I am going to get exclusively aldehyde. This double bond is going to be intact, where nitrile is going to be reduced to aldehyde. So nitriles, we can do preparation of aldehydes, and very important reagent which has been asked in all sessions is diibal, diisobutyl aluminum hydride, a reagent which is specific for the reduction of nitriles. Diisobutyl aluminum hydride. It can be written as diisobutyl aluminum hydride, or you can get it as like this. The representation is important, students, because you may get in exam in any form, or you can write it as diibal H, or you can get it as diibal H, no space. So what is this reagent? It is very important reagent where this aluminum is having hydride, which is negatively charged hydride. Yes, it is a metal, is going to have positive charge. This hydride is going to have negative charge, and isobutyl 1 2 3 isobutyl. You can have the structure like this also. In some exams you may get like this structure also. So this is the overall reagent diibal H, and it is very pyrophoric, means it burns in air. Pyrophoric, and its handling is very important. Dear students, I made a video how to handle these reagents. Please go through that if you have any doubts, because its handling and their quenching, means how to destroy after use, it's very important, and you are going to use this kind of reagents at higher classes or during your research only. So diibal H is the reagent. Yes sir. Khan not coming, okay. Mishra, okay. Voice not clear. Just a moment, let me check. Yes students, is it okay my voice? Dear students, so Vivek, you are saying my voice is not clear. Right, thank you. Clear. Yes, so pyrophoric, aluminum hydride is a pyrophoric reagent, so its handling must be done under very specific conditions. Anyhow, regarding our chemistry, so this diisobutyl aluminum hydride specifically reduces nitriles to aldehydes. So this only one hydride is going to be given. So this nitrile, when I add diisobutyl aluminum hydride, it is going to give aldehydes. This is one of the methods for the preparation of aldehydes from nitriles. And not only this, and another one more category of compounds diibal H is going to reduce. What is this? What is that? It is ester. Ester to aldehyde. So in carboxylic acids I am going to explain in detail. For example, if I take long chain acid ester CH2 taken 9 times, and this is ethyl ester, and when I treat it with diisobutyl hydride, I can write diibal H. Diibal H, it is going to give aldehyde. This is very important concept, students. You have been asked in 2019 JEE mains number of times. In all sessions you got diibal H based questions. Yes, so it is stopped at aldehyde stage only. However, in place of diibal H, if I use LaH, lithium aluminum hydride, it is going to reduce this aldehyde also to alcohol. So LaH is not going to be used. Diibal H has to be used. So diibal H is very specific reagent where nitriles, this is cyanide, I can say cyanide or nitrile, and esters. Please remember or write down somewhere. Dibol H is going to give aldehydes and esters also aldehydes. However, during really speaking, when you are doing synthetic chemistry and you have to do very fast reactions and you have to do very fast workup under anhydrous conditions, otherwise it is going to reduce further. So simply as soon as add your dibol H and do the workup. Anyhow, that is practical problem. So when it comes to preparation of aldehydes, you can prepare from nitriles and esters. Then a very important name reaction sessions come, students. So do you have any methods for the preparation of benzaldehyde? So entire chemistry, lot of chemical reactions and name reactions moves around benzaldehyde preparation from toluene. Let us see what are the name reactions available for the preparation of benzaldehyde. Yes, dear students, if you have any queries or doubts during session is going on, you can write down so that I will answer while session is going on. So preparation of aldehydes, let me take specific example, benzaldehyde. There are 4 types of reactions available for the preparation of benzaldehyde from toluene. Let me take one by one. When I take toluene, this is toluene, students, and treat it with chromyl chloride, CrO2Cl2, chromyl chloride. This name reaction is Etard reaction. Most of the times you will get questions based on name reaction. So Etard is the name of a scientist. In previous, just now what I said, Rosenmund is a scientist name, and stannous chloride reaction is a Stephen reaction, student. Just now I forgot to mention Stephen reduction or reaction, right? So when it comes to this benzaldehyde preparation, Etard reaction, chromyl chloride, it is going to form chromyl complex. This is chromyl complex, chromium complex. When I do further hydrolysis using acid hydrolysis, it is going to break here to give chromic acid and the benzaldehyde. And this benzaldehyde preparation, these 4 methods are very specific and important, and which are has to be remembered throughout your life, because these questions you may get during your interview also. So if you are already completed your PGR degree and you are going to work as a chemist, and these questions are sure, I am sure you are going to get these questions, right? Anyhow, so this is one method, and the second method is oxidation using chromium trioxide and acetic anhydride. Toluene, chromium trioxide in presence of acetic anhydride. What is acetic anhydride? CH3COO I can write like this also, acetic anhydride, right? So acetic anhydride in presence of chromium trioxide, it is going to oxidize tool into benzaldehyde. And the intermediate is, you may be asked this intermediate also. OCOCS3 and OCOCS3. Yes, so this intermediate is going to hydrolyze upon acid hydrolysis to give benzaldehyde. This is second method. And the third and important commercial method for the preparation of benzaldehyde is from toluene by halogenation followed by hydrolysis. Toluene, when I do halogenation, free radical halogenation, this is alkane. How to do halogenation? Use chlorine gas in presence of light, that is HNu. HNu is a light. Yes, students. So light, you are going to get dichloro benzol. So two chlorines are going to be added. This upon hydrolysis at 100 degrees centigrade, these two chlorines are going to be hydrolyzed to take up water and to give benzaldehyde. This is very, very important method and commercial method. Yes, student. So it is a commercial method for the preparation of benzaldehyde. Next. And one more very, very important name reaction under the preparation of benzaldehyde is Gattermann-Koch formylation or aldehyde preparation. What is Gattermann-Koch reaction? Anyone? Yes, students. Gattermann Koch formylation. What is this reaction? Take benzene and treat it with carbon monoxide in presence of dry HCl. So it takes up carbon monoxide in presence of anhydrous aluminum chloride, or I can use cuprous chloride, CuCl. Yes, so this takes up aldehyde carbon monoxide to give benzaldehyde. Yes, students, I have made video on detailed mechanism of this Gattermann-Koch formylation. You can go through that. That link I am going to give below of this video. So these are the common methods for the preparation of aldehydes. Let us see the preparation methods for the ketones. So ketones can be prepared starting from Grignard reagent, for example RMgX, and when I treat it with cadmium chloride, transmetallation. The concept is transmetallation. Please write down transmetallation. At lower classes it may not have that importance. Metallation. So what is happening? So here cadmium, this is magnesium. It is going to exchange with cadmium. It is going to take up alkyl groups, two alkyl groups here, R2 plus magnesium. X is already here, 2X is here, and 2 chlorines. That means X and chlorine 2. Right? It is balanced. This cadmium, alkyl cadmium compound, when I treat it with acyl halides, for example 2 moles of acyl halides, and this acyl halide is going to react with cadmium alkyl group. Yes students, what is the charge on this? Yes, usually it is negatively charged. This is also negatively charged, this is positive. Now this chlorine which is there on this acid group or acyl group, it is going to take up this. Yes, since we are using 2 moles here, let me write 1 R CO, this chlorine going out, and it is going to be taken up by cadmium. Yes, so let me take one more here, 2R OCl. It is going to take up this and it is going out to give 2 moles of ketone. Yes, I can write here R prime CO, and this is the R which is coming from here. Yes students, so both are same. So this is how cadmium chloride. So transmetallation can be done to get this acid from acid chloride to ketones. Ketones can be prepared via cadmium chloride. Then very important method is from nitriles, Grignard reaction of nitriles. This is one method, and second method is nitriles via Grignard reaction. When I take nitrile CH3 CH2 CN and treat it with alkyl phenyl. Let me take phenyl magnesium bromide. Yes, so this is Grignard reagent in ether. Usually where do you do diethyl ether? Let me take ether as a solvent. So this phenyl group is going to add to this carbon, and we are going to get imine as an intermediate CH3 CH2 CN, and this is magnesium bromide, and remaining is benzene ring. This upon hydrolysis, it is going to give ketone. Can I write like this? C double bond O, and this is CH3 CH2. What is this compound? Common name of this propiophenone. Yes, so this is another method of preparation of ketones, and very important methods for the preparation of ketones is Friedel-Crafts acylation. Friedel-Crafts reaction. What is that? Can anyone? Yes, students. So Friedel-Crafts reaction, what are the reagents we use for the acylation? What is this reaction? Aromatic electrophilic substitution reaction, right? So Friedel-Crafts acylation reaction is an acyl carbocation is going to be substituted on benzene ring. So what are the reagents? So benzene, let me take benzene. When I treat it with CH3CO, acetyl chloride in anhydrous aluminum chloride in a solvent, carbon disulfide is a solvent where its boiling point is around 50 degrees centigrade. I am going to get acetophenone. So can anyone write the mechanism? It is very simple. The first step involves generation of carbocation plus aluminum chloride. It is going to generate acyl carbocation CH3. This is carbocation or electrophile. Generation of electrophile aluminum chloride minus. The second step is formation of sigma complex. What is going to happen? Benzene, which is there, is going to take up this to give sigma complex. So this in third step it is going to lose hydrogen, removal of hydrogen. So this is common to all aromatic electrophilic substitution reactions, these steps. So removal of hydrogen, you are going to get acetophenone. This is how you can prepare ketones. Dear students, you can prepare aldehydes and ketones following these are the methods which are commonly used and versatile methods where there are specific examples and modern chemistry also is there, but at this stage these are enough to learn. Yes students, do you have any queries or doubts in these chapters or in these topics? Please write down. Right. Let us move forward. Just a moment, friends. I am refilling pens. Dear students, welcome to the series of organic chemistry reactions and chemical reactions of aldehydes and ketones. Dear students, please subscribe my channel Venus Academy if you are not yet subscribed, and don't forget to click on like button and bell button. Just now we have learnt about aldehydes and ketones, their preparation and structure. Let us see the chemical reactions of aldehydes and ketones. So during the structural elucidation, what I said, it is a planar molecule. Aldehydes and ketones are planar molecules, trigonal planar molecules. So if I write it on a plain paper, it is going to be aldehyde or ketone. It is a planar molecule. So what happens in nucleophilic substitution reactions? So please write down these, students. Nucleophilic substitution reactions. Carbonyl compounds. Write down this. Carbonyl compounds undergoes nucleophilic substitution reaction. It is very important, students. Nucleophilic substitution reaction. Whereas alkenes, so alkenes are the compounds similar to this. Alkenes undergoes electrophilic substitution reaction. Yes, so this is a major different way carbonyl compounds undergoes nucleophilic substitution. That means the reagent going to be added is a nucleophile. Nucleophile first adds to the carbonyl carbon. Why? These are the compounds having resonantly stabilized carbon, which is going to have partial positive character and this oxygen is negative character, right? Because of resonance. What are the resonance structures? So it can take up this double bond to be stabilized, oxygen as negative charge, and remaining is going to be same. So this is going to have resonance structure of this carbon positive and oxygen is negative charge. Because of this resonance polarization, so carbonyl compounds undergoes nucleophilic substitution. Let us take one nucleophile. So whatever will be the reagent, you will take a nucleophile, will have nucleophile. Let me write another one is hydrogen. So this nucleophile adds to this carbon where it is positively charged and it takes up this double bond to form, this is sp2 hybridized carbon. Now it is going to form carbon B, it is same A, and now it is coming above the plane, some plane, it is going to take up this orientation and oxygen is going to be negatively charged. What is the hybridization of this carbon? It is tetrahedral. Tetrahedral, and what is the hybridization? sp3. So carbonyl compounds during nucleophilic substitution, it undergoes sp2 to sp3 hybridization because it is strained, it is very easy, it easily undergoes this reaction. It is step 1, and step 2 takes up proton, or the nucleophile when adds here, it will have proton, it takes up this proton to give nucleophile, whatever may be the nucleophile, we learn different name reactions, and it is going to have in your higher classes. So this addition from above the plane or below the plane is going to have big stereochemistry, and that will follow some Kahn-Ingold-Prelog's rules, and there is stereochemistry. Anyhow, this is a nucleophilic substitution reaction where carbonyl compounds nucleophilic substitution reaction but not electrophilic addition reactions. Carbonyl compounds undergoes nucleophilic addition reaction, students. I'm sorry. Nucleophilic addition reactions. You should say addition reactions where addition of nucleophile is going to be added to this carbon and oxygen is hydrogen. So addition reaction, nucleophilic addition reactions undergoes nucleophilic Yes, students, let us write down. Carbonyl compounds undergoes nucleophilic addition reactions. Yes, so this is how addition will take place. So based on these nucleophilic addition reactions, what are the steps? So first step is addition of nucleophile. First nucleophile will be added, then followed by hydrogen or electrophile upon to oxygen. This is common mechanism about all these reactions. If you are through, then remaining all mechanisms are very simple and easy to understand. Next. So under nucleophilic addition reactions, we are going to learn about 5 reactions. What are they? Let me explain one by one. Yes, students, in detail all topics can be explained in 1 hour or 2 hours because every reaction will have lot of limitations, exemptions, right? So let me take one by one and conclude in a simple and easiest way, right? So the addition, nucleophilic addition reactions are, there are 5 types where aldehydes and ketones undergoes hydrocyanation. Hydrocyanation, let me take hydrocyanation. It can be aldehyde or ketone. aldehyde or ketones undergoes hydrocyanation upon treating with hydrogen cyanide. This is highly poisonous gas, hydrogen cyanide. However, this hydrogen cyanide is not that nucleophile. So what I will do is I will add NaOH. In presence of NaOH, this OH takes up this proton and gives cyanide minus. It's a strong nucleophile. So what is the step now? Nucleophilic addition takes place. So this is R and R. You can write R prime if you want, and cyanide is added. Right? This cyanide upon hydrolysis upon acid hydrolysis, it is going to take up this proton and to give O, and this is hydrogen has come just now. In generalized mechanism I have explained. So what is going to have here? Cyanide, and this is R prime and this is R, and this overall reaction is hydrocyanation. Yes, students. So during all these reactions, there is a general trend where this carbonyl compound, if it is aldehyde, this hydrogen is a small molecule or atom where nucleophile easily approaches carbon. So aldehydes are highly reactive. General trend, students, whatever may be the reaction, aldehydes are highly reactive. Yes, when compared to ketones. So if I take a ketone and R group and here also R group. So specifically let me take for example methyl group, the smallest group what I can put here. Yes, it is a ketone smallest group. This methyl group and this side whatever may be the group, it is a big group. So approach of nucleophile is not that easy. Yes, here it is vacant, here it is two bulky groups are there. So approach of nucleophile onto this carbon is tough. So reactivity of aldehydes is more towards nucleophilic addition reaction when compared to ketones. So that is why ketones are less reactive towards nucleophilic addition reaction when compared to aldehydes. Otherwise, yes, ketones and aldehydes undergoes nucleophilic addition reaction, but the rate of reaction is more or fast in aldehydes when compared to ketones. So this hydrocyanation will be carried out on aldehydes, at the same time ketones. And next is addition of sodium hydrogen sulfide. And it is very specific reaction, students. Addition of sodium hydrogen, sulfide. NaHSO3. So in this method, aldehydes are going to be reacted and aldehydes are going to be purified. Aldehydes gives this reaction. Ketones reluctant or this reaction. Ketones won't give, right? So by following this sodium hydrogen sulfide method, you can purify the aldehydes. Let me take one aldehyde, and when I treat it with sodium hydrogen sulfide, it is going to form sulfite. O minus, and sodium is there in the reaction mixture. It is going to form this sodium salt, oxygen, and remaining hydrogen is here. This is sulfonate, which is oxygen, and here SO2Na. SO2H. Yes, so this is how it is going to form intermediate. This takes up sodium salt to give O trans sodium. Sodium will be exchanged. Proton transfer will take place from here to here. Sodium will come here. So this is hydrogen, O, SO2, Na, and this side R group. Yes, students. So this is the sodium hydrogen sulfide compound, where upon hydrolysis simply add H plus water, you are going to get back your aldehyde. Dear students, this reaction is not that synthetic importance. However, you can use this reaction for the purification of aldehydes. Otherwise, it is not going to have that important in synthetic organic chemistry. Let us take very important reaction where you can do Grignard reaction. Grignard reaction of carbonyl compounds is very important, student. What is the Grignard reagent? Yes, students. So usually Grignard reaction we will learn based on carbonyl compounds. So Grignard reaction. Grignard reaction is very important, students. So if I take aldehyde, Grignard reaction, what is the Grignard reaction? Alkyl or aryl magnesium halide. How to prepare this? It can be prepared by adding magnesium in dry ether to the mixture of alkyl or aryl halide. So usually halide, bromine or chlorine. Chlorines are less reactive when compared to bromine. So alkyl halide, when you add magnesium taking in dry ether, you are going to get Grignard reagent. Alkyl magnesium halide is a Grignard reagent. This Grignard reagent, when you add, take this reaction in diethyl ether as a solvent, and diethyl ether or ether has to be dry. Yes. So in this reaction you can use tetrahydrofuran also. So tetrahydrofuran, there is a question in JEE mains. So this is also cyclic ether. Tetrahydrofuran can be used as a solvent in Grignard reaction. So usually you can use this THF. The common name is THF, tetrahydrofuran, right? Anyhow, so ether, you are going to get the addition compound, addition product. What is the charge on this carbon or whatever with alkyl or aryl group? It is going to have negative charge or nucleophile, and this is magnesium is electrophile. So this nucleophile will add to carbonyl carbon. Yes, to give an intermediate where carbon, oxygen is going to have negative charge, and this negative charge will be satisfied by magnesium, which is going to attach to this oxygen, and now this hydrogen is intact and newly added alkyl group will be here. Yes, students. So this is how it is going to give. And now when I do acid hydrolysis, it is going to give R, C, O, H and H. This is R. Let me write R prime here, right? So whatever with the R prime. So when I take for specific example, formaldehyde. What is the IUPAC name of this? Formaldehyde methanal. Because in your exams you are going to get as methanal. So it is aldehyde, right? And when I treat it with specific example or whatever with the alkyl group, magnesium halide, and I am going to get hydrogen, and this is alcohol, and this is R prime, and now hydrogen. So formaldehyde, only formaldehyde can give alcohols, and remaining aldehydes, if I take aldehydes, let me take specific example. CS3 acetaldehyde, and when I do RMGX reaction, I am going to get, what is this? So it is going to add to here, and I am going to get ketone. Yes, students, I am going to get ketone, and this is also aldehyde, but I am getting ketone. And when I take ketone here itself, secondary alcohol, secondary alcohol I am getting, right? So when I take ketone here itself and do RMGX reaction, this is primary alcohol, this is secondary alcohol, and when I take a ketone and do Grignard reaction, I am going to get CS3 and CS3. This R prime has come and this is tertiary alcohol. So this is how I can prepare primary, secondary and tertiary alcohols via Grignard reaction of aldehydes and ketones. So aldehydes, especially only formaldehyde, is going to get alcohol and remaining aldehydes are going to give secondary alcohols and ketones are going to give tertiary alcohols. Yes students, next.
Tennis.
Yes students, addition of alcohols to aldehydes and ketones, addition of alcohols, we are going to get acetal or ketol. Let us take one by one. So if I take aldehyde and when I add alcohol, in presence of dry HCl gas, HCl dry gas, we can generate HCl gas, right, from sodium chloride and sulfuric acid. Anyhow, so dry HCl, it is going to take up this proton, which is going to take up this proton first. This double bond O is going to take up proton first, and when it takes up proton, it is going to take up this, and now it is going to be accept this hydrogen and minus H plus to give RCO. O, H has come, and now this H is already here, and this is O R prime. This is hemiacetal. Hemiacetal. This further takes up another molecule of alcohol. Same alcohol, we have to use 2 moles. Yes students, so this further takes up, this is going to take up H plus to form this H water like molecule, and this is going out and it is going to come in to form R, C and H. I am going to write this side, and this is O R prime and this is O R prime. This is acetal. Dear students, so this acetal, when I treat it with aqueous HCl, it is going to hydrolyze very easily. Acetal to aldehyde we can get back by simple aqueous acid hydrolysis. So in place of this aldehyde, if I take ketone, and treat it with ethylene glycol. In previous example, I have taken 2 moles. So one molecule, 2 moles, 2 sides. Alcohols are two OH groups are there. I can write like this: CH2, CH2OH. Right? So ethylene glycol. It is very important, students. It will be learned during protection and deprotection reactions. Anyhow, so ethylene glycol in presence of dry HCl, it is going to form ketol. So R prime, and these oxygens are going to be like this 5-membered ring. So this cyclic compound we are going to get, this is ketol. The name is very important, students. Since we are getting from ketone, it is ketol, right? It is getting from aldehyde, we write it as acetol. So this is cyclic ether, yes, and it is, ketol is highly unstable, simply undergoes hydrolysis back to ketone in presence of aqueous HCl. That is why during this preparation we have to protect, we use dry HCl. So it is one of the ways to protect ketone during the reactions, where you have to protect this ketone. Yes, so this is how carbonyl compounds undergoes the formation of acetol and ketol reactions. Then next very important reactions is addition of amines. So there are, please write down this addition of amines. So various compounds are available under amines addition. So you are going to get different compounds. Yes, friends, if you have any queries or doubts, please write down. Addition of ammonia and its derivatives. Yes, students. So let me take one example. It can be aldehyde or ketone. Aldehyde or ketone, both, any one of these two. When I treat it with amine NH2, so nitrogen having 2 hydrogens, and this group Z, let me write Z. Z can be various types of compounds you can prepare. When I treat it in presence of this amine, is going to attack this carbonyl carbon and polarizing this oxygen to give R O NHZ, and this is R group is already here, and this intermediate is not going to be stable. It is going to lose water this intermediate is going to lose water minus water, so it is going to give imine Z group and remaining R groups. So this is imine type compound we are going to get. So overall what is happening? Simply this oxygen and this hydrogen is going out as water to form carbon and nitrogen double bond. So this is overall reaction, students. So throughout all these examples what I am going to give, it is going to form double bond, right? So if I take ammonia here, let me write like this. I am not going to write R groups here, plus ammonia or NH2 and Z, if it is hydrogen, what we are saying? Ammonia, right? So directly I will write this compound R group and N, this is H. This compound is imine. When I use ammonia, I am going to get imine. And when I use alkyl or aryl amine, let me confine to R group, R, and I am going to get minus water. Yes? So what is water? It is going this is water. Minus water, I am going to get N and R. This is substituted imine R. It is very important, students. This name has been used, will be used in your laboratory. Schiff base. So Schiff base. This is base, Schiff base. So please remember, I'll write down somewhere Schiff base. When I use this plus hydroxylamine, this is hydroxylamine, it is going to lose water, minus water, it is going to give nitrogen and OH. Its name is oxime. These names are very important, students. That is why I am cross checking and writing. So each compound will have different name, right? So hydroxylamine. When I use hydrazine, this is hydrazine. Minus water, I am going to get NH2. This is hydrazone. I am going to get hydrazone. When I use phenylhydrazine, phenyl, or you can write benzene in here if you want. Minus water, I am going to get phenylhydrazone. Yes? So this phenylhydrazone, in place of this simple phenyl ring, if I use 2,4-dinitrophenyl group, 2,4-dinitrophenyl group, it is very important reagent in organic chemistry, where it is used as a reagent for the identification of aldehydes and ketones. It is going to give colored compounds of 2,4-DNP, right? Phenyl hydrogens, 2,4-dinitrophenyl hydrogens. So this, when I use NH2 and this side NH and this phenyl ring, here let me write phenyl, and if this phenyl ring is substituted with 2 position para position dinitro, 2,4-dinitrophenyl hydrazine, 2,4-DNP. It is very important test for the identification of aldehydes or ketones, where it is going to form phenyl hydrazone, nitrogen, and this is NH, and remaining it is 2,4-dinitrophenyl hydrazone. It is bright yellow, orange, red, yellow, orange, red. So it is going to give the different colors, yellow, orange, red. Yes, students. So it is going to be identify aldehydes and ketones, where you can get this colored compound. It is solid, you are going to get. So simply take aldehyde ketone in test tube. When you add this 2,4-DNP, you will get crystals of this. Yes. So you are going to get solid of this orange, red colored compound. So this is how. So 2,4-DNP test is very important for the identification of these carbonyl compounds. And another very important reaction it undergoes is semi-carbazide. So it may not be visible. Let me use semi-carbazide here. So when I use carbonyl compound plus semi-carbazide, this is very important, student. That is why I am writing complete structure, so that you will not confuse. So this is NH and this is CONH2. This is urea, the nitrogen which is directly attached to this urea molecule, or this carbon is not going to react because it is resonantly stabilized. So it is inert. This nitrogen is going to form semi-carbazole. Yes, semi-carbazide. This is semi-carbazide. In your book it is not given like this. So I am writing in an elaborated way. Minus water. So this is going as water to give double bond in NH, and urea will be as it is. So this is semi-carbazone. Yes, students. So these are all very important names where you come across. So simply you will say oxime like, or ketoxime, aldoxime. Yes. So this oxime, if it is aldehyde, aldoxime. If it is ketone, ketoxime. Yes, students. So ketoxime, aldoxime, hydrazone, phenyl hydrazone, 2,4-DNP, 2,4-dinitrophenyl hydrazone, and semi-carbazone. These are all very important compounds names. So if you want, you can write down and remember these nomenclature or terminology, which is very important in your future classes also. Yes, students. So this is how it is going to add to ammonia and its derivatives. Next. Yes, students, since it is very big chapter, I am explaining each and every concept in detail. So, and it is very important chapters of organic chemistry. So please pay the attention. And if you have any doubts, you can raise or you can write your queries even during now or after this class also. Excuse me. Yes, students. Dear students, we have been learning aldehydes, ketones and carboxylic acid chapter. Just now we have completed preparation methods of aldehydes and ketones, and next we have come across chemical reactions of aldehydes. Under chemical reactions of aldehydes, we have completed nucleophilic addition reactions where hydrocyanation, sodium hydrogen sulfide addition, Grignard reaction, and addition of alcohols to aldehydes and ketones, and amine, ammonia and its derivatives, where we have come across imine, semicarbazone, hydrazone, oxime, 2,4-DNP test, right, like that. And now we are going to learn oxidation reactions of aldehydes and ketones. Dear students, please subscribe my channel Venus Academy if you are not yet subscribed, and don't forget to click on like button and bell button. Let us see oxidation of aldehydes and ketones. Oxidation, in principle, what is oxidation? Leoger. Addition of oxygen is oxidation, right? Or removal of hydrogen is oxidation. Yes, so let us stick on to addition of oxygen is oxidation. So already aldehydes or ketones are having one oxygen. This aldehyde, when I do the oxidation, so aldehydes easily undergoes oxidation reaction when compared to ketones. Yes, so mild oxidizing agents, for example, Tollens reagent and failing solution. I am going to give the equations for this. Failing solution, and these Tollens reagent failing solution is specific tests for aldehydes. Aldehydes only undergoes these reactions to give carboxylic acid salts, where Tollens reaction you are going to get silver salt, and this failing solution you are going to get, this is salt, I can write metal. Metal is M equal to silver. In Tollens reaction it is copper, right? So this oxidation, where when I do hydrolysis I am going to acid. aldehyde to acid takes place in presence of oxidizing agents, Tollens reagent or failing solution. So it is very easy to oxidize aldehydes to acid, and most of the times aerial oxidation itself is enough to undergo oxidation. That is why aldehydes has to be immediately used for the next step, otherwise it is going to oxidize by taking aerial oxygen to give oxidized compound carboxylic acids. So other common oxidizing agents where drastic conditions are strong oxidizing, these are mild oxidizing agents, and when I use strong oxidizing agents like HNO3, it is also one of the strong oxidizing agent, but commonly you will not use HNO3, so you come across with KMNO4, potassium permanganate or potassium dichromate, K2Cr2O7. These are very strong oxidizing agents. Yes, oxidizing agents usually oxidize these aldehydes to carboxylic acids. But ketones also undergoes oxidation use of strong oxidizing agents only. These ketones are not going to give this test, or ketones are intact. Ketones are not going to be oxidized using Tollens and failing solution. So strong oxidizing agents oxidize ketones. Use of KMNO4 or potassium dichromate. At the same time, they give different mixture of compounds where it is going to break in a different way, and it requires heating reaction conditions. Let us take one example. RCH2 CO CH2 R prime. So if I write down the numbering 1, 2, 3, when I add KMNO4 potassium permanganate and heat, it can break carbon 1 and 2, or it can break carbon 2 and 3. Yes, so if I write this is compound A, this is compound B. Let us write one by one. R, so this CH2 is going to be acid. So even it is, this CH2 is going to be acid. And place remaining, let us write from that side, and it is going to have this acid is acid and CH2 R prime. So it is the breakage of C1 and C2. At the same time, it can give the mixture of these compounds. It can break at C2 and C3. So C2, C3, what is going to happen? R, CH2, this carbonyl compound, yes, red color carbon is this side, OH, and now this blue carbon is going to oxidize to acid, and this is R prime. So this is how it will give mixture of compounds. Yes, students. So just now during the chemical reactions, what I said, aldehydes highly reactive or undergoes easy reactions when compared to ketones because of steric factor and electronic factors. Steric factor and electronic factor. Steric factor. Where ketones are hindered. Yes, students. So this is how Tollens reagent and failing solution are the two reagents which are used for the identification of aldehydes from ketones. Because if you give carbonyl compound, if it is a mixture of aldehydes and ketones, you are going to get 2,4-DNP test. Just now what I said, 2,4-DNP gives aldehydes and ketones group. Yes, it says the compound is having carbonyl compound. Then whether it is aldehyde or ketone, so For that identification, you have to go through this tolerance test or fading solution test. Let us take tolerance reagent and do the test. Yes, Yadav, what should I repeat? Anyhow. Yes, this is very simple, Yadav. So, aldehydes easily undergoes oxidation when compared to ketones. Yes, aldehydes, even use of mild reagents like tolerance reagent or fading reagent, it is going to give oxidized products carboxylic acid. Whereas ketones require strong oxidizing agents, where of strong oxidizing agents HNO3, we do not use HNO3. However, we come across with KMNO4 and potassium dichromate. These strong reagents, yes, also oxidizes these aldehydes to carboxylic acids, but these are strong enough to oxidize these ketones also under heating reaction conditions. However, it is going to cleave this ketone molecule at different sites. For example, this is a site where carbon 1 and 2, if it undergoes cleavage, it is going to give this side acid, yes, this side acid and this side acid. If it undergoes this, it is going to give this acid and this side acid. So this is how it is going to give 4 acids, 4 different acids it is going to give. So that is why. So ketones undergoes under drastic conditions oxidation. Let us take one by one and you will come to know the importance of these tests, tolerance reagent and fading solution. Yes, thank you, Yadav. Yes. Most of the times you will get a question, direct question, what is tolerance reagent and why it is used. Sometimes it will be asked in a direct way. Yes, let us see oxidation of aldehydes using tolerance reagent. So what is tolerance reagent? Tolerance reagent test or tolerance test. Remember students, ammoniacal silver nitrate. Ammoniacal silver nitrate is a solution. So simple students, take the aldehyde compound in your test tube and prepare freshly prepared solution of ammoniacal silver nitrate solution, where take ammonia and silver nitrate. Yes, in laboratory you will get silver nitrate and ammonia. Mix these two, ammonia and silver nitrate, you will get freshly prepared tolerance reagent. This is tolerance reagent. And taken in a test tube aldehyde. Yes, aldehyde taken in a test tube. When I add ammoniacal silver nitrate, it is going to release silver, and that silver is going to be form a layer, bright color layer, silver, you will see. And this test is also known as, so in your textbook it is not given, silver mirror test. So it may be asked in some entrance exam. Silver mirror test is tolerance test. So please write down this also. Yes, anyhow, I am going through all organic chapters. Yadav, don't worry, please follow my videos, Venus Academy. I am going to complete all organic part. Yes, Please follow me. Right. Silver mirror test. It is going to be silver mirror test where Torrance reagent is going to be silver mirror test where this silver is going to be formed as a layer on test tube. It is going to give bright silver color. So what is the equation? What is going to happen in test tube? This aldehyde, when I add ammonical silver nitrate, say 2 moles, don't worry about this equivalence, and during test just add ammonical silver nitrate and heat on Bunsen burner. In previous days we used to heat it on Bunsen burner, right? Silver, ammonical silver solution. It is going to have positive charge, nitrate charge, and in presence of base 3-hydroxy, we are going to get oxidized aldehyde to acid RCOO minus, and it is going to form silver ion, then 2H2O, and remaining is ammonia. Yes, 2 into 2, 4. So this silver is going to be formed as layer on test tube. So this test is also known as silver mirror test, and this test is given by aldehydes only. So Tollens test is given by aldehydes only. So please write down if you want, aldehydes only. Next, failing solution. Failing solution, you will get 2 solutions separately and you have to mix before the testing of this aldehyde, same way. Failing solution A, in laboratory you will get failing solution A. It is aqueous solution of copper sulfate solution. And failing solution B, it is sodium potassium tartrate salt, alkaline solution. Students, it is base solution. Alkaline means it is there in alkaline solution. Alkaline sodium potassium tartrate. Thank you, Yadav. Alkaline tartrate salt. So before testing your aldehyde, take this copper sulfate solution A and alkaline sodium potassium tartrate solution B and mix to give this failing solution. That failing solution is nothing but it is going to have copper 2 plus ions and base from this alkaline solution, where aldehydes gives color compound. That color compound is coming from copper. So it is a color test. So it is going to form this solution copper sulfate plus alkaline sodium potassium tartrate salt. It is going to give aldehyde plus 2 copper 2 plus ionic state and plus 5 OH to give acid. This minus charge I am putting here, actually silver salt, we will get here copper salt, right? Plus cuprous oxide and water. So this cuprous oxide is a red brown PPT, a red brown precipitation. Dear students, most of the students are missing practicals. Don't worry, this test usually you are allowed to do in your lab during your intermediate or plus 2 level, tolerance test and failing solution test. So you will get red brown PPT and this is silver mirror test. It is very simple reaction where you can do immediately, you can identify whether the given compound is aldehyde or not. So this is how you can identify और tartarate क्या है? It is very simple, student. Tartaric acid. This is tartaric acid. You will come to know. So this is tartaric acid. So in next biomolecules chapter we are going to get tartaric acid. This tartaric acid, when it is attached to sodium and potassium tartarate. Yes. So here, if you want, you can write carbon and hydrogen. So this is sodium potassium tartarate. Tartaric acid tartarate. Anyhow, just remember like this. You are not going to be asked what is the structure of this. If you want, yes, sodium potassium tartarate. And this is having very important role in stereochemistry, where this salt was first picked up by using hand lens, where this is D-tartaric acid. This hydroxy group is right side, D-tartaric acid. And anyhow, I am out of syllabus now. This is out of syllabus what I am going to explain. So this side it is another L-tartarate and D-tartarate. This is, and these two are diastereomeric mixture, diastereomers. These diastereomers are going to be differ with melting point and shape, and just by using hand lens, the scientist, I am not sure, Lee Shackler, name I am not sure now. So he picked up and separated these two compounds. So that is how it is very important compound to know the structure in stereochemistry. Anyhow, so this tartarate, here it is not required to use D or L. Both will give the same test. So that is why we write it as sodium and potassium tartarate. Tartaric acid, tartarate. Right? I hope. Yadav, is it clear? Right. Next. So this is how you can use tolerance test and failing solution test for the identification of aldehydes. Next, students, very important reactions where you will do hyperhalous test, where iodoform test. It has been asked in every time. Iodoform test is asked in all NEET and JEE mains test 2019 and 2020 also. It has been asked, and it is very important concept, where this test is given by methyl ketones and hydroxy methyl compounds. Oxidation of methyl ketones by haloform reaction. Do you know chloroform? What is the formula of chloroform? CHCl3. It is chloroform. And if it is CHBr3, bromoform. If it is CH iodine, iodoform. So you may be asked chloroform test, iodoform test, bromoform. So in general, haloform test, haloform reaction. Haloform reaction is given by the compounds having R methyl group. This methyl is important. So this methyl is going to form as chloroform or bromoform or iodoform. It is very simple, students. When I use sodium hydroxide plus, for example, bromine. So this bromine and sodium hydroxide, it is going to form sodium OBr. This sodium OBr, or you may get it as NaOX. X can be chlorine, bromine or iodine. Whatever the X, you are going to get here as iodoform, chloroform or bromoform. So this is going to react with these methyl ketones and to give RCOONA plus, and this methyl is going to react with, for example here I have taken bromine, so bromoform or iodoform I am going to get. So this methyl containing compound group is very important to remember, students, right? So at the same time, the same compound, if the structure is having, so this is where you are going to get in exams. So sometimes the structure may have like this compound. It may be some R, blah blah blah, some R compound. So if it is added sodium hypohalous, this is sodium hypohalous test. So when it is added to NaOX, what is going to happen? Is it going to give or not? So this is very yes. Yes, students. So it is better to follow Shiva Krishna, right? Shiva Krishna, it is always wise idea to follow your NCERT book. But care must be taken. The key points they are writing in a simple way. They are giving one sentence or one word, and based on that word only they are giving number of times questions based on that word. So for example, this is very important. That is what I am going to stress. So this hydroxymethyl ketones, alpha hydroxymethyl compounds also gives iodoform test. So based on this you are going to get questions in your JEE or NEET. So we generally remember in our mind that methyl ketones gives haloform test. Everybody knows this methyl ketones. But hydroxymethyl compounds also gives this iodoform test or haloform test, and that is why, so keenly read your NCERT book number of times, and please try to attend this type of lectures of me or some other is going to teach better way. You can attend their lectures in YouTube or somewhere else. But so the key points, what is there in your NCERT book is going to be asked in your JEE Means and NEET, because if the question comes other than your NCERT book, it is not going to be treated as from your syllabus, and it is going to be out of syllabus, and it is going to be cancelled, or it will be added some bonus point, or it is not going to be considered as a valid question. So that is why always depend on NCERT, but don't read just like a novel. So the key points what I am going to explain. So this methyl ketones gives haloform test. Everyone knows methyl ketone gives haloform test. So it not going to end at this stage. It is going to be very key that it is going to give hydroxymethyl compounds, where addition of this hydroxy sodium hypohalite, it is going to form this ketone type intermediate, where it is going to form this, and it is nothing but it is going to be formed in the reaction mixture. To oxidation takes place with bromine NaOX. Oxidation takes place, and it is going to form intermediate and bromine like that, and it is going to give same this haloform test. Yes, students. So this is how it is going to give haloform test. So simple, students. The mechanism is very simple. So sodium hypobromate, it is going to form bromination takes place, alpha halogenation takes place to ketone, and it is going to break into halo form. Right? So the important thing is methyl ketones and hydroxymethyl compounds undergoes this haloform test to give identification of methyl ketones only. Other than methyl ketones, you are not going to get this test. Yes? Next. Yes, students. So very important reactions of aldehydes and ketones is, we will complete this reductions. No, reductions part. Let me complete reduction part before moving forward. Reduction of, it is very important, students. Most of the time specific reagents are there, that what I am going to explain. Reduction of aldehydes and ketones. So the simple reducing agents are, it may be aldehyde or ketone, students. So the reagents, please write down. The reagents usually we come across is sodium borohydride or lithium aluminum hydride or palladium on carbon hydrogenation. Yes, so the cheapest reagent what we can use for the reduction of these ketones to alcohols. Aldehydes gives alcohols, primary alcohols, ketones gives secondary alcohols. This is OH and hydrogen. Yes, so reduction, what is reduction? Just now what I said, Leo-gel. They again stick on to Leo-gel. So lending of electrons is oxidation, or gaining of electrons is reduction, or addition of oxane is oxidation, and here addition of hydrogen is reduction. So stick on to this reduction step. We are adding hydrogen, H2 we are adding to the ketone or aldehyde to give this alcohol. Yes, students. So the easiest way or easiest or cheapest material. Yes, Yadav, I have explained already, Gatterman Koch. Yes, so during formulation, the preparation methods I have explained. Yes, you can go back after the class and check it. Yes, so this is, and a detailed explanation and all mechanism of Gatterman Koch is already there with Venus Academy. You can check back. Lot of examples are given that are Gatterman Koch formulation reaction for the sake of CSI and NET people. Yes, advanced mechanism is written at that stage. Okay. Sir, are you pace? Yes, so for your it is very simple. Gatterman formulation, it is nothing but, I have given in this also. So carbonyl compound, it is carbon monoxide. It is neutral electrophile. Neutral electrophile, where it takes up this first step in presence of acid, dry HCl gas, to give this hydrogen is going out, so that everything is explained during that. Anyhow, let us continue this reduction of sodium borohydride, lithium aluminum hydride in presence of palladium carbonate hydrogen. So here question comes. So is it, can I use sodium borohydride or lithium aluminum hydride for the reduction of these two? Yes. So it is not specific. However, this sodium borohydride is cheap. You can use this cheap reducing agent. Compared to lithium aluminum hydride is costly. At the same time, it is highly pyrophoric. Care must be taken while handling this aluminum hydride. And palladium carbonate is very costly reagent, and it is has to be done under extreme care conditions. So the easiest method for the reduction of sodium borohydride is of ketones and aldehydes is use of sodium borohydride. Yes, students. Next, and the two name reactions where we come across Clemmensen reduction and hydrogen hydrate. Yadav. Yes, I am going to. Anyhow, let me check that. Don't worry. Dear Yadav, see, I am stick on to JEE means and NEET. There are n number of reagents for the reduction of carbonyl compounds, right? So I have made already video on open R oxidation and NPV reduction, but in your textbook, these are the reagents. I am sticking to these reactions or reagents, right, Yadav? So don't worry. If you want further about oxidation and reductions, yes, there are number of videos in Venus Academy itself. So for example, during the MPV reduction, I have explained lot of reducing agents. Please go through that. Don't worry, right? So I am sticking on to JEE and NEET mains, right? So at this stage, you are enough to learn the difference or the selectivity of these reagents. Yes, students. So have you come across MPV reduction? Mean Pondorf reducing agents. So there are number, don't worry. So ketones in presence of sodium borohydride, lithium aluminum, palladium carbon. Then next. So there are two name reactions which are given to you, that is Clemmensen reduction where you will use acid catalyst or in acidic medium zinc amalgam in presence of HCl. Let us see aldehyde or ketone. Yes, in presence of zinc and amalgamated zinc. So this is amalgamation will be done to activate zinc. Amalgamated or copper couple also you will get, right? Usually zinc amalgamated zinc in presence of HCl, you are going to get reduction compound where hydrogen is going to be added to this to get this reduced compound. And the mechanism is very simple, students. First it is going to take up the electrons from zinc. It is going to donate 2 electrons to form carbon. Sorry. So this carbonyl compound, it is going to take up H plus ions to form and now the carbocation which is going to be formed is going to take up zinc 2 electrons, transfer of 2 electrons, and this zinc is going to be out as 2 plus to give R negative OH. And this takes a proton to form carbon and R and OH. Now what is left over? H plus ions. This oxygen takes up R, OH, H, and this is positive. It is going to lose this carbocation, takes up zinc, another molecule of zinc, -2 plus to give carbanion. Thus that carbanion takes up proton to give this reduced alkane. The key thing is, the key factor is this: it is acidic medium. So acidic medium, if the compound is having ketol group, just now what I said, ethylene glycol ketol group, this ketol group is going to be cleaved. So this ketol group also is going to be cleaved, and this carbonyl compound is going to be reduced to hydrocarbon, or 2 hydrogens will be added to this. So the compound which is having acid labile group. Yes, students. So please concentrate this type of key points. When the compound is having acid labile group, that compound is not useful in Clemmensen reduction reaction. Right? So Clemmensen reduction is not useful for the compounds which are having acid labile groups. Next, Wolff-Kishner reduction. So what are the reagents used for Wolff-Kishner reduction? In Clemmensen reduction, we have used acid. So to overcome that acid labile group cleavage, Wolff-Kishner reduction. Dear students, don't worry. This is specific chapter what I am teaching for the people, those who are preparing for JEE and NEET. Right? So another videos are going to be made, and there are a number of videos are there in Venus Academy for the people, those who are preparing for CSIR NET, GATE or BARC and IIT JAM. So in that I am going to give number of examples in a different way, and if I teach in that way, it takes each reaction, it takes 1 hour. That what I said. So Clemmensen reduction already I have kept in Venus Academy. Please go through that. You will get number of examples under Clemmensen reduction. So Wolff-Kishner reduction. So Wolff-Kishner reduction, whether it is aldehyde or ketone, in presence of hydrogen hydrate, what I am going to get? When I treat it with ketone or aldehyde with hydrogen, I am going to get hydrazone. This hydrazone, it can be isolated. This hydrazone, when I do treat it with KOH, base, hydrolysis and heating, I am going to get this alkene. Yes, students. So, for example, I have, this is the compound, acetophenone to ethyl benzene. I can do with this reagent. Yes, students. Let me write the mechanism. So up to here, no question, no doubt. So these hydrogens are acidic enough to taken up by base. So OH, it takes a proton from this nitrogen to form minus, nitrogen minus, this nitrogen minus comes here, carbon minus, this is N, double bond N and hydrogen. So this, at this stage, another molecule of KOH takes up this proton to form nitrogen minus, and before that it takes a proton to give carbon, nitrogen, and nitrogen, it is minus, already one hydrogen is here. When it comes here, and this bond is going to be, yes, it is going to taken up by this carbon to give carbanion, plus nitrogen goes out, carbanion, this carbanion takes up proton which is there in the reaction mixture to give this alkane. Yes, students. Yeah, don't worry. Since because of this corona and all, most of the teachers are not teaching in a classroom, so you will get. Yes. So the thing is that concentrate on basic things, right? Basic things. What I am teaching is specific to your board. So in your board, it is not going to ask some extra, which is not given in your textbook. So, yes, don't worry, you will be topper if you follow your NCERT. I try to stick on to NCERT and solve all the questions which are there in your NCERT book. Okay, don't worry. So, this is, and the key points what I am going to say is very specific for entrance exams, because Wolff-Kishner reduction is a base catalyzed reaction. Yes, so Wolff-Kishner reduction is a base catalyzed reaction. Clemmensen reduction is a acid catalyzed reaction, and both the products are same. Starting materials and products are same, but the reagents are different. Because of that reagent differences, each reaction, Clemmensen reduction and Wolff-Kishner reduction, is having different roles. Yes, don't worry. So this is how you can do Wolff-Kishner reduction. Next. And the reactions based on alpha hydrogen, you will have number of reactions. However, I am going to stick on to two reactions, because these two reactions are there in your textbook. That is aldol reaction. Under aldol reaction, we are going to get crossed aldol reaction and aldol condensation reaction also. Then the second one is Cannizzaro reaction. And based on this Cannizzaro and aldol reaction, the key point is dilute sodium hydroxide, concentrated sodium hydroxide. So base, dilute and concentrated base is important. So please concentrate on that points. Okay, wish you happy birthday, Yadav. I hope you right. So, Usman, maybe just now you are arrived. Don't worry. So let us concentrate on the compounds which are having alpha hydrogens. So wish you happy birthday, Arjun Yadav, and this is Usman CH. So Usman, just follow from now itself. You are going to understand. If you are not specific about any point, let me know. That I will explain once more. Alpha hydrogen. Let me take aldehyde, for example, alpha hydrogen containing aldehydes and ketones. Let me refill. Just a minute, student. I am refilling pen. Yes. So alpha hydrogen containing compounds, the compounds are aldehydes which are having alpha hydrogen. What is alpha hydrogen? Yes. So if I take this is the compound having alpha hydrogen. It is ketone having alpha hydrogen. This is aldehyde having alpha hydrogen. The carbon which is attached to carbonyl carbon is alpha carbon, and the hydrogens which are attached to alpha carbon are alpha hydrogens. So based on this alpha hydrogens, there are n number of reactions in organic chemistry, but we are going to learn few of them, that is aldol and Cannizzaro reaction. So this hydrogen which is attached to alpha to this is going to be labile and it is acidic proton. In presence of mild base or dilute base, it is going to lose, alpha hydrogen is going to be loose, so it is going to lose. For example, base I am going to add, it takes a proton to form this conjugate base and it is going to form CO minus and hydrogen is here and this is double bond, enolation takes place and this is conjugate base. This is conjugate base we are going to get. This conjugate base is stable because of resonance stabilization by oxygen negative charge. This O minus is stable, that is why this conjugate base is going to be stable. This hydrogen is going to be easily goes out with simple mild base. So the compounds which are going to have this alpha hydrogen undergo specific reactions. Let us take one example and see. Aldol reaction. Let me check aldol reaction. Yes, students. So simple example, if I take CS3COH 2 moles, this is acetaldehyde in presence of, remember this, dilute sodium hydroxide, or I can take 1% NaOH, aqueous NaOH I can use. Yes, 1%. 1% means 1 gram in 100 ml. So blindly I can say yes. So conjugate base, why it is stable? It loses proton and it takes up here. So if it is this conjugate base is loses proton and if it is available it takes up this. So oxygen is always pulling these electrons towards this oxygen. So this stabilization it is going to enolize and it is going to be resonance stabilization. Yes. So that is why it easily loses proton only in presence of base. Otherwise, if there is no one to take up this proton, why it is going to lose? So when someone comes to take, that is base is there in a reaction mixture or in a reaction mixture, then only this is labile. Why it is labile? Because the conjugate base which is going to be formed is going to be stable. It is not in a hurry of taking up proton or whatever maybe that comes in, it is ready to take up. It is stable because the oxygen with negative charge, it is electron negative atom, it takes up O minus and stable. Right. That is what I am going to say. As it is when aldehyde in a solution, when there is no base, this is stable. It is not going to form enolation. Right? For example, do you know this compound? Anyhow, this is all out of syllabus. So this is ethyl acetoacetate. Ethyl acetoacetate. This is ketone form, and it always in a mixture of tautomer. This is tautomerism. This takes up. Yes, students, don't worry. And enol form is more in ethyl acetoacetate because this enol is easily formable. This is highly acidic proton because this enolation takes place very easily. Yes? So stick on to this, don't worry. Further examples. So in presence of base, this is highly labile proton which is acidic proton. Alpha hydrogen is acidic proton because the formed conjugate base is going to be stable where oxygen is having negative charge. Right. So dilute NaOH, stick on to dilute NaOH. If I add concentrated NaOH, it is going to be different reaction. So dilute NaOH, I am going to get CH3, OH, hydrogen, CH2, aldehyde. This is aldol product. Aldol. It is not a name of any scientist, not a name of any scientist. It is a reaction where we are going to get aldehyde and alcohol. So that is why aldol and alcohol. Yes, students. So it is aldol reaction. This aldol upon heating in presence of acid or base, since the reaction is in basic condition, it is going to lose water to give this double bond compound. So what is happening here? It is simple aldol reaction where two molecules, what I am saying, it is acidic proton. So let me take this example and explain. In presence of base, dilute NaOH, let me write OH minus here, and this OH takes up this proton to form carbanion. Yes, students. So this carbanion is going to react another molecule of acetaldehyde to form. So let me take this blue color carbons to form hydrogen, this is O minus, and this hydrogen, let me write down, and this is CH2 and COH. Yes, So in solution, it is done in aqueous solution. It takes a proton from the reaction mixture to form CH3, CH, CH2 aldehydes. So this, when I heat it is going to lose, I can write here minus water to give this double bond compound. This is simple aldol reaction, and the condition, it must have at least one alpha hydrogen. At least one alpha hydrogen. If it do not have this alpha hydrogen, it is not going to form the product. That reaction is going to be Cannizzaro reaction, that I will explain. Right? This is simple aldol reaction. So if I take mixture of two different aldehydes, what is going to happen? And here itself, so let me write here, if it is ketone, right, if it is ketone, same thing going to happen. You can write down like this, same thing, ketone, it is ketone, so add methyl here. Yes, students, if it is ketone, if I take ketone, I am going to get this compound. And one more thing, it is not given in your book, that one more thing is that, so what I am saying, right, ketones usually do not undergo aldol reaction that fast. Aldehydes easily undergoes aldol reaction very easily. Yes, students. So this is what aldol reaction is, can be done in between aldehydes and ketones. So let me take mixed aldol reaction or crossed aldol reaction. So when I take different aldehydes, it is going to undergo crossed aldol reaction. Crossed means two different aldehydes, CH3, CH4. So in this case, I am going to get four different compounds. What are they? So just now we have come across these acetaldehyde products. Let me write acetaldehyde products straight away. Double bond products, let me write, right? CH3, C, H is here, double bond, CH, this aldehyde. Yes, student. So from here, CH3, CH2, C and double bond, and coming from this, so this is alpha hydrogen. In this case, this is going to be out. So this methyl is here, hydrogen. Yes, students. So these two are self-condensation products. So this is self-condensation and this is self-condensation. This is one compound one. You are going to get mixture of compounds. You may be asked what are the mixture of compounds. Yes? For what? Gattermann-Koch reaction. Anyhow, I will send you later. If you are not getting, after this class I will send you. Don't worry. The link I am going to send you. So this aldehyde. Next, so if it reacts with this, let me write. How to write? So the third compound CH3. This is CH2 is going to be here, and this hydrogen double bond and this carbon. So if I write, this is CH3CuO4 CH3 and this is blue color, and this is hydrogen and this is aldehyde. This is one compound, third compound, and it can attack from this side. CH3 hydrogen here double bond, CH3 double bond C, and here which one is going to attack? This is the carbon which is going to react. Yes, it is alpha hydrogen. So this carbon hydrogen, and it is already attached to methyl group. So it is methyl. Now this aldehyde is going to be intact. So this is how you are going to get four different products and mixture of products. That is why I have made a video. Please go through Aldol reaction. Yes, Yadav, if you want, you can go through this Aldol reaction, Venus Academy, where you have different starting materials where you divide off this alpha hydrogen containing compounds. For example, if I want specific reaction, benzaldehyde plus this CH3 COH, what I am going to get? Cinnamaldehyde. So that is why use the aldehydes which are devoid of alpha hydrogen one component, and other one is the compound having at least one aldehyde. So to overcome this type of mixtures, usually aldol reaction will be done by taking one compound which is not having alpha hydrogen and other compound having alpha hydrogen. So this reaction is usually done for the preparation of aldol cinnamaldehyde type compounds. So this is cinnamaldehyde. Yes, students. Next, Cannizzaro reaction. So where in this reaction, what is the base? Dilute NaOH we are using. So dilute means very weak base. Right. If I use strong base, what is going to happen? Cannizzaro reaction. The spelling is CANNIZZARO. So this reaction is self-oxidation and reduction reaction, self-redox reaction. Reaction which is also known as reduction and oxidation takes place. So you are going to get two products. One is oxidized, another one is reduced product. For example, if and the condition is the aldehyde should not have alpha hydrogens. No alpha hydrogen containing compounds undergoes this reaction. Where, for example, formaldehyde. This is formaldehyde. Two molecules are now the base is concentrated NaOH. I can take KOH, NaOH, some base you can take. So Yadav, please type Aldol reaction Venus Academy. You will get it. Don't worry. There is a video. So formaldehyde in presence of concentrated sodium hydroxide, I am going to get a reduced product, one compound, and other one is oxidized product. Yes, so methanol I am going to get, and formic acid. If I use here benzaldehyde, concentrated NaOH, I am going to get benzyl alcohol plus benzoic acid. Yes, so how it is going to take place? Let me take this benzaldehyde example itself. When I add NaOH, so this is negatively charged. Nucleophilic addition takes place. First step to form O minus, hydrogen is here, and this is OH. Yes, students. Now another molecule comes into picture. Where this O minus comes back, and this hydrogen along with bond pair, it is going to add to this another carbonyl compound to give one is isn't it acid already formed here plus this is O minus, and one hydrogen is already there, and this hydrogen is added to here. Now it is in a reaction mixture. Yes, students, and there is sodium salt also is there, right? This proton, it is acidic proton, so proton exchange takes place. Proton exchange takes place to give, this is salt form. When I add acid, it is going to H plus ions, it is acid salt form, sodium salt form, and this is alcohol plus this O takes up the proton from acid to get this alcohol. And this, when I add H plus ions, it is going to take up this H plus to give acid. So from the aldehydes which are not having alpha hydrogens undergoes self oxidation and reduction. This is oxidized product which is acid. It is reduced product which is benzyl alcohol and benzoic acid, and you may be asked to write only up to this stage. Sodium salt of benzoic acid also you can write if you are asked to write. So mechanism of this Cannizzaro reaction. Yes students, so this is how you can write the mechanism for Cannizzaro reaction, and you can check the Cannizzaro reaction with Venus Academy. I have given lot of examples under Cannizzaro reaction. Yes, next. And when it comes to aldehydes, aromatic aldehydes are ketones. When it comes to aromatic electrophilic substitution, what is the orientation? Incoming electrophile, where it acts? Is it activating group or deactivating group, aldehyde or ketone? Yes students, in your entrance exams, especially JEE and NEET, you will be tested on your understanding, not just writing number of pages. Okay. So please concentrate on the key points what I am going to explaining while other reactions are named reactions. Anyhow, so electrophilic substitution on aromatic aldehydes, what is the orientation? Where it is going to undergo? If I do nitration, what is the nitrating mixture? Nitric acid, sulfuric acid, and usually it undergoes 0 to 10 degrees centigrades. It is enough, right? So these are the positions: ortho, meta, and para. So where the nitro, incoming electrophile is nitro, NO2 plus, where it is going to electrophilic substitution takes place on benzene ring. Aldehydes and ketones, write down students. Aldehydes and ketones are deactivating groups. Deactivating groups, and these orient the incoming electrophile towards meta directing groups. Why meta directing group and how? If you write the resonance structures, so this carbonyl compound is electron withdrawing group. Electron withdrawing group. So oxygen withdraws the electron pair of pi bond, and from ring it is going to form resonance structures like this. Yes. So here what is the charge? It is plus charge. So ortho position, what is the charge? Plus charge is forming. And what is incoming charge? Plus charge, electrophile. So is it possible to attack here? Already it is electron deficient. This is also electron deficient. So electron, incoming electrophile is not going to attack onto this ortho position. So further, it resonance stabilization takes place to form this para position positive, double bond, hydrogen, O minus. So what is the position? This electrophile is formed, or carbocation is formed at para position. So the electrophile is not going to attack at para position also. Yes. So further it is going to form this side. So same this side also ortho you can write, and meta. Right? Both the sides same, symmetric. It is going to form this carbocation O minus. Yes, students. So this back to its original position to form benzaldehyde. So during these resonance structures, what is happening? The carbocation is forming at, so it also is not going to take place, whatever may be the position. So the carbocation during the resonance structures of benzene, the carbocation is formed at ortho and para. So that is why the carbocation or electrophile, incoming electrophile NO2 plus is not going to attack onto ortho and para. So the leftover is meta position. That is why the carbonyl compounds are aldehydes, aromatic aldehydes and ketones are the compounds, meta-directing compounds. So the nitration takes place at meta position. Meta-nitrobenzaldehyde. If you want, what is the mechanism? The first step is generation of electrophile H2SO4H plus HNO3. This is HNO3 and sulfuric acid. So in this case, generation of electrophile, it will have three stages. In your previous class, you have learned electrophilic substitution reaction involves three steps. The first step is generation of electrophile, where this OH is going to, HNO3 is going to act as base and sulfuric acid is going to act as acid. It gives H plus ions to form HSO3 SO4 minus plus, this is O, hydrogen, and this is NO minus, and it loses water molecule to give NO2 plus. This is the electrophile where it is going to attack onto meta position. Yes, students. So this meta-nitrobenzaldehyde is going to be formed in aromatic electrophilic substitution reactions of aldehydes and ketones of aromatic compounds. Yes, students. So this is how you can learn aldehydes and ketones. Dear students, I hope you enjoyed this topic, and if you have any queries, please write down in comments box. Even after completion of this chapter also I am going to explain, and the remaining the carboxylic acids I am going to teach in next class. Till then, bye. We will meet again. Sayonara. Arigato gozaimasu. Yes, students, I forgot to teach physical properties of aldehydes and ketones. Let me complete that also. Physical properties of aldehydes and ketones. Yes, students. For example, if I take formaldehyde, it is a gas. If I take acetaldehyde, it is volatile liquid, means low boiling point liquid. And the first ketone, when I substitute this with methyl group, what is this? It is acetone, and its boiling point is 56 degrees centigrades. Dear students, it is going to be liquid. Formaldehyde is a gas, acetaldehyde is a volatile liquid, and it is a liquid. Acetone is a liquid. And the more homologs you move forward, it is going to be liquids or higher solids, or higher homologs are going to be solids. Yes, students. So the key points what you have to focus is aldehydes or ketones, boiling points are higher than hydrocarbons, and ethers. Yes, students. So boiling points of aldehydes and ketones higher than these hydrocarbons and ethers. What are the hydrocarbons we have learned? For example, alkane, alkene, alkyne, and benzenes. Yes. So similar, if you take acetone, for example, acetone, so 3 carbon containing compound, and ethyl methyl ether. If I take this similar compound, methoxymethyl, and the boiling point of acetone is higher than the ethers. However, lower than alcohols. Why alcohols are going to be high boiling solvents? Because alcohols are having hydrogen bonding, whereas these aldehydes and ketones are not going to be have hydrogen bonding. Intramolecular or intermolecular hydrogen bonding is not possible in ketones or aldehydes, right? So alcohols are high boiling, whereas hydrocarbons and ethers are going to be less boiling point containing than these aldehydes and ketones. And when it comes to solubility, yes, students, any guess? So when it comes to solubility, formaldehyde, acetaldehyde, acetone, water soluble. So lower compounds water soluble, 100% water soluble, means miscible with water. When this chain goes on increases, so sparingly soluble or immiscible. Yes, students. So that is how. So the solubility depends on the molecular weight. So the lower molecular weight containing compounds are soluble in water, because these compounds will form hydrogen bonding with water. If it is water, so it is going to form water hydrogen bonding with water. So that is why acetone is soluble with water, and acetone is used as solvent for the washing also in organic synthetic laboratory. Yes, students. So this is how physical properties, nothing much to worry. Usually you will be tested on the boiling points based on these hydrocarbons, ethers. And one more key point is, so straight chain compounds, suppose it is straight chain compounds will have high boiling points, compared to branched chain. Branched chain compounds will have low boiling point. So these are physical properties of aldehydes and ketones. Thank you students. Thank you for watching this video. Please subscribe my channel Venus Academy if you are not yet subscribed, and don't forget to click on like button and bell button. We will meet again with carboxylic acids. Till then, bye, sayonara, all the best, arigato gozaimasu. Bye students.